Hey everyone, you is me Deepak. So today here we'll be covering very important concept called as bloom filters. It's an efficient data structures for modern applications. Means I could say that bloom filters are probabilistic data structures that efficiently determine whether an element is a part of a set or not, offering significant space and time savings at the cost of potential false positives. They are particularly useful in applications like recommendation engines and web crawlers where space efficiency is crucial. Means I could just, in a simple word, I could say that uh, they are approximate data structures, also known as probabilistic data structures. Why? Because it gives the probability, not the exact, whether an element is present or not. Means I could just say that, means it says that with the 100% certainty that an element does not belong to a set. It says it with the 100% certainty, but whether it's belong, it's not sure about it. It can give correct result, might be wrong result, but whether an element does not belong to a set, it will say this with a 100% certainty. How? We'll be looking into it. Let's say here, the characteristics makes Bloom filters particularly useful in scenarios where efficiency in space and speed are critical. Let's say considering a scenario where Instagram has a feature of reels. Okay, considering a scenario where Instagram wants to recommend reels to users. So here I want to recommend reels to a users. I don't care about the recommendation engine, what kind of algorithm I'm using. That's a different concept, as a different topic. That's a different video. So here I just have to see that I want to recommend. How it's recommending, okay, that's a different thing. But here I want to recommend. That's the thing we need to consider. We need to keep that in your mind. Okay, so here it is essential for the platform to avoid recommending reels that users have already watched. Okay, so here to achieve this, Instagram needs a mechanism to track which reels each user has seen without consuming excessive memory or processing time. So here let's say I'm a user over here and I have watched, this user has watched this specific reel. Okay, this specific reel. So here why would I watch this again? Let's say I'm, okay, take God their case. I watched it twice, thrice. That's up to me. But in my feed, when I'm scrolling from here, I'm getting the same reel. When I'm scrolling, I'm getting the same reel again. When I'm getting scrolling, I'm getting the same reel again. Keeps on repeating the same reel. So here this should not be the case. Okay, so here what I want to do, what I want to achieve over here, that if this user has watched this reel, I don't want to populate this specific reel into the feed of this specific user. So miss, no duplication has to be there. Unique reels I wanna populate or display or render onto the UI of the user. So here in this case, you might think, miss, the brute force approach or the traditional approach is that a straightforward solution is might be involving storing the IDs of all the reels into a set, because set stores unique keys only. So here, however, as users might watch hundreds or thousands of reels daily, okay, the size of these sets can grow significantly. Now you will say, okay, so what's the big deal? I will simply, let's say I got this key for reel. Before populating it into the feed of a user, I'll be simply checking it into the set, okay, whether it is there or not. Okay, it is there. So I won't be recommending it. I won't be populating it, ingesting it onto the user's system, user's Instagram feed. That's simple. But to bring this set into the, but to access this set, I need to bring that into the disk. That disk I operation will be there. let's say somewhere else. So here the network I operation will be there and the computation will be there, CPU computation. This whole thing is very expensive. Okay, means here it will be having much more processing time. There will be excessive memory usage, which is not a good thing in an engineering, because we work for that time only. In order to decrease as much as I can, means the time I need to decrease the processing time of it. Okay, so here storing these sets on disk will require loading them into memory for existence checks, which is both time consuming and memory intensive. And this is not an only issue. Let's say a user is watching hundreds of reels, thousands of reels in a day. There could be millions of users. So that for the millions of users, there will be millions of sets where I'll be maintaining the which reels they have watched into a set. And for that specific user, I need to bring that into that set into the disk. That memory access, that processing time, all will be the expensive, much more expensive, which is not a good idea. Where the birth of Bloom filters is now. So here to address these challenges, Bloom filters were introduced. So what's the key insight behind Bloom filters is that once a user has watched a reel, that information is permanent. They cannot unwatch it. Okay, that's the real scenario also. Let's say I have watched this reel, key 4. It's not that I will unwatch it. It's not the case, because it's not like or unlike. I could do that like unlike, but here if I watched some reel, how could I unwatch it? It could not be the case, na? Okay, that's considering this constraint, and this is also a constraint of the Bloom filters when I'm comparing it with the set, because I mean it's a trade-off of the Bloom filters. Okay, that insertion if it is inserted, it will be getting inserted for permanent. I can't remove it. It's the trade-off of Bloom filters, and we are okay with that in order to achieve, in order to complete our use case. Okay, so means trade-off means it's like a situation where a decision needs to be made between two or more desirable features, means where improving one aspect often remains sacrificing another. Because in our life, let's say two things are that both of are important. I won't be able to get the both. I could get either of them, either one of them. So I need to pick one. That's a trade-off. In the technology as well, in the engineering part as well, there could be time and space trade-off. While optimizing an algorithm to run faster might require using more memory to store intermediate results, might be the trade-off between performance or security. If there is if I do need a higher security, I need to compromise with the performance. If I need a performance improvement system, then in that case I need to compromise with the security. If do I want flexibility, I need to compromise with the simplicity. If do I want simplicity, I need to compromise with flexibility. Means the whole engineering is filled up with the trade-offs. Okay, and here the trade-off is that I could not remove inserted whatever the key I have ingested in my Bloom filter. Okay, good. So we'll be looking into an example over. Let's say here I do have a filter, or I could also say that this filter has a bit array. I'm considering here a bit array of 1 byte, which is 8 bits. That's why I have marked with from 0, 1, 2, 3, 4, 5, 6, 7 indices, 0 to 7 indices. Okay, so here uh, Boolean filter is just a simple bit array or a filter to represent the existence of elements. Okay, when an element is added in this, it is processed through a hash function which generates an index in the bit array that is set to 1. Let's say for example I do have Deepak. I want to insert this key into this filter. How could I? So let's say I'll be applying hash function over it and doing mod with the 8. Why 8? Here I'm doing mod with that value which is the length of my bit array or the filter. In my case it's 8 bit. Let's say if it is of 20 kb, then the length will be simply 20 into 1024 into 8 bits. I'll be doing mod with that value, but here in my case it's 1 byte, which is simply 8 bits. So here I'm doing mod with 8, and here I got the 3. It's not the actual value which I got after calculation. I'm just assuming it is just a random value which I have picked up. Okay, so here 3. At the place 3, I will see, okay, there is nothing. Nothing is here in an array. It's initialized with 0 only. There is nothing. Miss 0. So here I'll be marking it with 1 in order to denote that, okay, Deepak has been encountered. This Deepak has been, I found the Deepak key while iterating or something like that. Then I found Sinchan. Same thing I'll be doing, applying hash function, doing mod with 8. I got 6. I'll be marking 6 also with 1. Let's say now I got Doraemon. So here while applying hash function in this, doing mod with 8, I got 3. Okay, but here I see that 3 is, when I go and when I went there and saw, okay, 3 is already marked with 1, which means Doraemon is already visited. I already watched this, but it is not. Up till now, I only watched these two things, Deepak and Sinchan. That's it. So it's the wrong thing. We'll be looking into it. Okay. So here I'll mark it with the 1. So let's say here just now I saw that in just 1 byte, that is 8 bit, I stored this much of keys on all this stuff. I do not need to store the exact object or exact read, exact post, which is also space efficient in my use case. So let's say I wanna fill. Let's say I wanna insert now in just Kitaresu. I'll be doing applying the hash function, doing modified. I get 2. Okay, I get 2. So here I'll be placing. Okay, is there anything at 2? No, nothing is there. So here I'll be taking this 2 and placing. I'll be taking 1, marking 1 at place 2, which means Kitresu. I have watched the Kitresu. Okay, good. Now I'll come and insert Pikachu. I got the value as 3. I'll come here to insert 1, but here it is already marked with 1, which means I have already watched Pikachu. But it's not the case. I didn't. It is marked by someone else. I don't know it is marked by whom. It's marked by someone else. It's not marked by Pikachu. That's an issue with the bloom filter. So here applying hash function and the Kitresu, I got 2. So here at the filter at position 2, there is 0. I am when there I got 0, I marked with 1. Okay. When I did hash function to Pikachu, I got 3. So here at filter 3, at position 3, when I go there, it's already marked with 1. That's which should not be the case. So here bloom filter says what? That is, if it is not present, it will say with 100% certainty that it's not present. But whether it is present or not, it will not be sure about it. It might present or not. Just now we saw this thing. Whether Pikachu present or not, I'm not sure. But Kitresu is not present. I'm damn sure about it. At the start, Deepak was also here in the case in the at index 3 it was 0. Here, here. The which is not present, I'm damn sure about that with the 100% certainty that is this specific thing is not present. But whether it is present or not, I'm not sure about it. It might present or not present. Okay. So here let's say I'm keep on adding the words in on this man and the marking 1 for the specific word in my this filter. I'm in this here insertion increases. So here I'm marking the bit will be marked as 1. So here after certain time all the places will hold 1. That's for sure. Now even if I put the word, I apply hash function doing mod with my length of filter, I'll be getting some value, and when I'll come to my filter, it will be marked already with 1, which says that the specific word which I have is already present, which is not the case. It's not present. That's an issue. Means here, the moment insertion increases, the bit array or the filter will get filled up after a certain time. So here, the moment ingestion increases, false positive rate is also increases, which is the problem in the bloom filter case. So initially, as we know, initially there was no element, so that's why the whole array was marked with nothing. That means zero. The moment I keep on increasing, keep on putting, keep on being populating it with the keys, it is filled up with it is marked up with 1. So here, by this also, it's directly proportional to the false positive rate. The false positive rate will also get increased with this, okay, with the size. So here is the trade-off of bloom filter, that is the false positives, and also the trade-off of the false positive is that fixed size. So here I could say that, we could say that, okay, it is, if it is filled up, let's simply increase the size of it now. But I won't be able to here in the case of bloom filter. Let's see if I'm able to do this. So what will happen? Okay, so here whatever is already calculated, I need to do that mod with that new bit array length. Let's say I'm doing with the 16 bit, so I need to do with mod with the 16. So I'm not sure whether I'm getting the 3 again or not, some other value. So here the whole array will get mismatched or something like that in the haphazard manner. The all will be get marked. This is not a good idea. Okay, that is the trade-off of the bloom filter. So what the solution could be? So here I need to tune the size of the bloom filter. Means what do I actually need to do is that we have to recreate bloom filter with larger size than my earlier one and populate these keys which I have ingested in my last bloom filter again, estimating the maximum keys and provision a large one to store with. Okay, so here let's say this blue one is a bloom filter which is filled up. Okay, now I have recreated another bloom filter, this red one, big enough to store more data than this one, blue one. I'll be recreating this bloom filter. I'll be populating this bloom filter with whatever the keys my last bloom filter ingested. Okay, might be I'll be storing for that particular time in database or something like that. In this way, I could just solve a specific problem. Okay, so here let's now look into the practical applications of bloom filters. So here, bloom filters could be used in, let's say, recommendation engines. It is used in various scenarios where data is inserted but not removed. If I'm okay with the thing that data is inserted but not removed, then I'll be like, okay, I'm okay with that. So I could just simply use this bloom filter in my application. Okay, good. Means here, before using into a certain system, I need to check whether uh, insertion is okay, but remove I won't be able to remove. If I'm okay with that, good. So here, if you need a no with 100% certainty, then in that case as well, we could just simply go with the bloom filter. And let's say having false positive is okay for me, in that case, as well, I'll just simply go with the bloom filter. Okay, so the applications of bloom filter, it could be, let's say, recommendation engines. Let's say platforms like Medium, where articles are getting published. So here I could use bloom filters to track articles read by users, ensuring they do not recommend previously read content. Let's say I'm reading content, I have read an article about bloom filters. So if I'm getting again and again and again the same blog repeatedly, so user will get frustrated. Let's say in the YouTube, one a user have watched some video, it's a video, and again the same video is getting populated onto his or her feed, which should not be the case. It's not a good idea. Okay, so in that case I could just simply go with the bloom filters. Okay, let's say out of thousands and lakhs of videos, if hundreds or ten or 100 videos I'm not able to get, that's not coming in my recommendation, because while uh, rendering onto my UI, while populating the feed for me, it's saying it is already there because of that marked one, because of the false positive issue of the bloom filters. I'm okay with that. Then in that case I could simply use this bloom filter now. In the case of web crawlers as well, let's say bloom filters help avoiding here recrawling URLs. Why would I recrawl it? Means which have already been visited. So it could save bandwidth and processing time for me. Let's say in the social media like Tinder, there I could use the bloom filters to ensure users do not see profiles they have already swiped on. Just now I told you that example of YouTube videos. Let's say out of lakh or crores of videos, if I'm not getting recommended with that tens or hundreds of videos, I'm okay with that. It's not recommending because of this false positive issue. If I'm okay with that, I'm good to go. I could simply use the blue filters. Okay, so here I could just use blue filter with Redis, which is a popular in-memory data structure. It stores and offers native support for bloom filters also. How? That means here user can create a bloom filter in Redis, specifying its size, its false positive rates, and then insert data without worrying about the underlying implementation data. All the things will be maintained by Redis over there. So for concluding this bloom filter, we have covered almost everything which you should be aware about. That is a powerful tool for efficiently managing large sets of data. Here I covered only a small set. It could manage large sets of data where space and speed are critical. They provide a way to quickly check for the non-existence of elements while accepting a certain rate of false positives. If we are okay with that false positives, good. You can simply go with bloom filters. Understanding how to implement and utilize bloom filters can significantly enhance the performance of applications that require fast data retrieval and minimal memory usage. Let's say for the practical exercise, considering setting up Redis locally and experimenting with bloom filters to see how they work in practice. This hands-on experience will deepen your understanding of this fascinating data structure. So here, thanks for watching. Hope you like it. Bye bye.